All right, so we're back. This is lecture 4 of CS164. So today we dive into the part of the course for which you probably have all been here, which is namely the iOS aspect. Along the way, your mind will probably get a little bit bent by the syntax that we're about to see in a language called Objective-C, but you'll see that a lot of the issues that we've been talking about over the past several weeks of the semester will recur. So even if some of the syntax and some of the jargon actually seems new, realize that almost all of these ideas have we seen before. So books. There is a non-trivially sized list of books in the course's syllabus. Most of them you don't really need, frankly, for the course, and they're all only recommended, not actually required. But for this part of the course, for what it's worth, these two books are actually quite useful. So this is a book akin to what we used in CS50 for C. This is the Objective-C counterpart. It's a little dense, and it's a lot of pages, so it's not the sort of thing that you use so much as a reference. But if you really want to learn the underpinnings of the language and really exit the course knowing Objective-C in and out, this is a particularly good reference. If you're more interested in the iOS aspect of the course, which uses Objective-C, but Objective-C can be used outside of the context of iOS, this is actually a really good book. As I mentioned in the first lecture, it's pretty, it's colorful and whatnot, has nice code examples. It's also been updated for iOS 5, which is the version of the software development kit that we'll be using for the course. And I mentioned this book more than I would typically mention books in a course, because there's a lot of crappy documentation out there, or lots of crappy tutorials on the internet. As iOS has gotten popularized, and same for Android, everyone and anyone has a blog about how to write iOS software, but it's not necessarily correct half of the time. And even Apple's documentation, while very rich, is horribly organized. And so it's really hard to go through it from start to finish. It's much more of a sort of you Google your way into the innards of Apple's documentation. So this is actually quite a helpful reference. So if you're on the fence about getting any books, this is probably the one to choose if you would find that helpful. So this is the kind of stuff we're going to start seeing today. Hopefully it should bring back fond memories of C, albeit with some new syntax. But before we dive in, let's try to explore some of the topics that we will have to start taking for granted in this new world of iOS. So iOS is very much object-oriented. Objective-C itself is a proper subset of C, which means it supports all of C plus some more stuff. For those familiar, it adds essentially object-oriented features to C, hence the objective in Objective-C. So what did we mean over the past few weeks, or from CS51 if you've taken it in years past, by object-oriented programming? What is OOP all about? What do you got? Okay, so in object-oriented programming, you have classes, and classes have methods, which are functions that are sort of built into these classes. And classes also have one other defining characteristic. Besides methods, they also have values, properties, data, some kind of data members inside of them. And this is consistent with this buzzword known as encapsulation or data hiding, where inside of this object you can put all sorts of pieces of data, just like you do in C with what construct in C supports the same notion of encapsulation. Yeah, so structs in C. But structs in C are relatively primitive, and they can't really support methods. They kind of can. If you're familiar with something called function pointers, perhaps from CS61, you can actually associate with a struct an actual function, but the language just wasn't really designed with this in mind. So Objective-C, PHP, C#, other languages support actual objects which have methods and data associated with them. Now, when we talked about PHP a couple weeks back, we did use this phrase, data hiding. What do we mean by hiding data inside of a class? Who cares? What's the motivation there? Yeah?
You can essentially prevent like a client-side user from manipulating the data in a way you don't want them to.
Perfect.
Sort of change implementations without them having to worry about, worrying about specific stuff. Is it an int? Is it a float? Et cetera, et cetera.
Yeah, exactly. You can hide some piece of data, like say a student's name, and you can store it however you want, as one big string, as 2 strings, first name and last name, as 3 strings, first, middle, last name, as 4 strings if you have a title or a suffix to the name. But you can still expose that data to the user, but in an immutable way, by providing them with some convenience method, like an accessor method or a getter method, whose sole purpose in life is to return that data or some formatting thereof. of. So this is generally a good thing, especially when you start working with a partner, because now you and your partner, as you've perhaps experienced for Project Zero, can decide on what functionality each of you is going to provide to the other, but he or she doesn't have to worry about the underlying implementation. And similarly, if 6 months hence on that same project or some real-world job, you decide that, wow, an n-squared algorithm was the wrong way to implement this particular method, it doesn't matter to your partner because you can go back in, retool it, and so long as you maintain the same API, the outward-facing code, then it's no problem for your friend or partner. So in PHP, let me go ahead and open up a terminal window. We have this ability to define a class. So let's say this is, say, student.php. And I'm going to go ahead and do class student. And then we'll get started here. And just a couple data members. What do we typically associate with a student? Sorry? So a name. OK, so we have a name. So we might say something like, we could say public name, and that's going to be a string. What else might we have? Public year. So we might have year. That might be an int. And let's leave it at that for now, because we don't really need more to discuss this. So public is sort of the cheat here, right? If I'm specifying public, that means that a user can access members of this class using fairly familiar syntax. So now if we go down here, I can do something like s gets new student. And that's going to create in memory a student object. And if I want to assign this student a name, I can simply say David. And if I want to assign David a year, I can do something like this. But I have to decide here, is it going to be quote unquote? Is it going to be an int? And so these are among the sort of design decisions that you've perhaps had to consider for Project Zero. But this is not the best design. Why? Let's be extra clear here. We're encapsulating the data, but we're not really doing anything more than a C struct. Why? What's bad about this design? Yeah, Zach. Yeah. So now I have this ability, which might not be what I intend, to actually change the name to be something completely different at some point in my code. And maybe this is a complete accident, right? Maybe there's just a bug. But the fact that I'm exposing myself to this risk is generally not a good thing. Plus, for all the reasons we discussed a second ago, if I want to hide the underlying implementation of the name, I might not want to expose Tommy or David as the name, but rather those might be one of several fields that are hidden inside of this object. So in version 2 of this, when we've tinkered in the past, we instead did something like private, and now we have a private name, now we have a private year. So now this syntax is no longer valid. You will actually get a compiler error because the compiler or the interpreter will realize that that's a private data member. You're trying to access a private field, and so no, you may not do this. So the code won't in fact run properly. So how do we fix this in PHP? Yeah, so we need some kind of function or method inside. So typically, we would do something like public function, and let's call it getName, though we could call it really anything we want. And it's kind of a stupid method, but we can just say this name. And then similarly, can we have public function getYear, and then we could say return this year. And just as an aside, can you make methods private? OK, so you can, but why would you? Because clearly now, if that's private, similarly, can I not access it lower in my file?
So you can use the public methods to encapsulate functionality.
OK, so you can use public methods to encapsulate functionality, but when might you want a private method?
So to encapsulate it even further.
OK.
So because it's used in a public method.
Ah, good.
Good.
Good. So especially in Project Zero or now Project One, if you find yourself copying, pasting code, especially in a project like Project Zero, where you have a lot of entities like a course or a faculty member or a student or whatever, however you've modeled your world, there might very well be chunks of code that you're kind of using all over the place to format names of a course versus names of a professor or the like. And so those kinds of things in theory can be factored out into private methods, into some other class altogether. So you certainly can have private methods if your own public methods therefore call those. And that's not something that your partner would even have to know or care about. So for now, we've got this. Unfortunately, we still don't have one capability. This syntax still doesn't work because I'm trying to set name and year. So what else do I need to add to the mix here? So setters, right, or mutator methods, as they're sometimes called. So the convention typically there is to call it something like public function set name, and then I've got to take an argument in this case, and then I might do something like this, name gets name. However, I could do some validation, right? I could say if strlen = 0, change the name to something default, like unnamed student, or something like that. So with setters, you have this ability to exercise some data control, whereas you don't have have that for something like this naive approach down here. And let's do the similarly, public function set year. And this is a much better candidate for some validation, because at the moment, I could pass in really anything. But what might I also want to do in this case when setting a year? This is a prime candidate for some kind of data validation, right? So before I actually set the year, I could do something like, if it's not the case that year matches a regular expression like this. So if unfamiliar, this is just a regular expression. Rather, let's say the positive. If